Right, so week 2 we're looking at inequations. First few types of questions we're looking at now. So show the following inequalities on the number line. Alright, so you've got your number line here, and you just need to work out where the number 5 would be. You don't actually need to write every single number, so you could do a few, maybe 4, 3, 6, 7, just so you understand the position. So x is bigger than, we do a circle that we don't fill in, and if x can be anything bigger than 5, it's a line that goes off forever in this direction. So that shows x is bigger than 5. Next one, x is less than or equal to minus 3. So we draw our line in. We could have minus 3, minus 2, minus 1, 0. Less than or equal to means we colour it in. And less than means it's any number that can be less than negative 3, so it goes this way. Maybe put one in more in, so it's a bit more obvious what it looks like. Everything that's less than negative 3. Next one, between negative 3 and 5. So let's draw this one in. So minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. When you're between them, you probably want to put a few more numbers in. 1, 2, 3, 4, 5. Bigger than negative 3. And less than 5, we don't colour them in because it's not equal to, and it's anywhere between there and there. Next one, between negative 4 and negative 1, number line, minus 4, minus 3, minus 2, minus 1, equal to the 4 as well, but less than the 1, and we join that up with a line. Alright, 1 mark each. Number 2, solve the following. These work exactly the same as equations because it's plus 1 here, we minus 1, x is bigger than 4. In the book they do plus 1 minus 1, 5 minus 1, but I prefer this way, it's the same. So this one, so we multiply by the 2 to get x plus 1 is less than or equal to negative 6, and then we minus the 1, so x must be less than or equal to negative 7. For this one, again, it's just like an equation. 3x must be bigger than 5 minus the 2. 3x must be bigger than 3. Divide by 3, x is bigger than 1. And for this one, I'm going to do this shorthand because you kind of get the idea. Multiply by 4, and then subtract 4. X is less than negative 24. Alright. When we've got these ones, obviously we want our variables on one side, so we get 4x minus the 3x must be bigger than 7 minus the 1, therefore x must be bigger than 6. For this one here, I'm going to multiply this side by 2 to get x plus 1 is less than or equal to minus 6x plus 10, and move the minus 6x and take away the 1. 7x is less than or equal to 9, divide by 7, x must be less than or equal to 9 over 7. Come down here. Alright, so move the x's. 3x minus x is bigger than minus 6 minus 2. 2x is bigger than minus 8. X is bigger than negative 4. And here I'm going to times this by 10 to get 10x plus 40. Cross multiply, times this by 4 to get 8x plus 12. Then move them. 10x minus 8x is less than 12 minus the 40, so 2x is less than, again, if you're not too sure, just use your calculator so you don't make a mistake. Minus 28, divide by 2, x is less than negative 14. Pretty much 2 marks per question. Include this level of working out. Next side. Alright, now we've got some exceptions here. I'll show you what I mean. So leave the minus 3x, and then it becomes 3, take away the 5. So minus 3x is bigger than negative 2. Now because we're dividing by a negative, minus 2 divided by minus 3 is just 2/3. The sign actually changes. Now the reason is, pick a number that works here. So for example, if x was 0, it works. 5 minus 0 is 5. 5 is bigger than 3. So it works when x is 0. Which means, is 0 less than 2/3? Yes, it does. So it works here as well. If I left this sign the same way round, it wouldn't work because 0 is not bigger than 2/3. So when you divide or multiply by a negative, the inequality changes direction. So let's do this one. I'll just rewrite the question out. So you take away the 4 to get minus 3x is less than or equal to minus 6. Now when you divide by a negative, it changes direction. So when we divide by negative 3, minus 6 divided by minus 3 is positive 2. X must be bigger than or equal to 2. So when you divide by negative, it changes direction here. So I'm actually going to look at where my biggest x is, and I'm going to leave that there and move this to plus x. So I get 8 is greater than 5x. Divide it, so 8 over 5 is bigger than x, or x is less than 8 over 5, or 1.6. Here I'm going to cross multiply, so minus 10x plus 40 is less than 8 minus 4x. I'm going to move the 10x to this side, so 40 minus the 8 is less than minus 4x plus 10x, so 32 is less than 6x. Divide by 6, and you probably want to do that into a fraction. 16 over 3 is less than x. If you did it the other way around, you'd end up having to change the sign halfway through, but I didn't divide by a negative because I kept my variables on the right hand side. 5. Graph the following linear equations. Now to graph something, there's a few ways that you can do it. The most efficient way is to understand where the intercepts are. For example, this crosses at 0, 1, 2, 3, 4. The y-intercept. The x-intercept is minus this, so minus 4 divided by 2 is negative 2. So that's the 2 points it goes through. You only need 2 points to plot the line. Because it's not equal to, it must be a dotted line. There it is. So that is the dotted line, which means we do not include the line. Now because y is bigger, we want everything above the line. And y is bigger than 2x plus 4 is anywhere in this shaded section works. So anywhere in this shaded section works, and obviously there's an infinite amount of coordinates above the line. So let's do this one. So let's graph what we need. It goes through at minus 4, minus 1, minus 2, minus 3, minus 4. Now minus x minus 4. So to find out your x-intercept, it's minus that, which becomes positive. 4 divided by negative 1 is negative 4, minus 1, minus 2, minus 3, minus 4. So they're the coordinates that it goes through. Now this time it's a solid line, because we're including it, and y is greater than this line is anywhere here. Now a way of checking if you've shaded the correct side is pick a coordinate that you think is correct. So I'm obviously going to pick 0, 0. If you substitute 0, 0 into here, it should work. So is 0 greater than or equal to negative 4? Yes it is, so it works. So usually you can substitute a coordinate to check. This one definitely works, which means this must be the side that was shaded. Next one. So I'm just going to have to do a bit of solving here. So I'm going to divide by 2. Y is bigger than x plus 2.5. We're going to show where this would look like. So our intercepts would be at 2.5, 1, 2, 3 there. And minus that divided by 1, 1, 2, 3 is there. It's bigger than. So we do not include the line, and it's above it, so we shade this section here. Now to prove this one's correct, I'm going to pick the origin again, 0, 0. Technically that should not work in this. So that would say that 0 is greater than 2.5, which doesn't work, so we don't shade in this side. I did get it correct. Let's rearrange this one. So times this side by 2. 3 minus y is bigger than or equal to minus 2x plus 2. Then I'm going to take away the 3. Minus y is bigger than minus 2x minus 1. Now I need to divide by negative 1. And when you divide by a negative, the sign changes. So let's just double check that this works. First of all, let's graph it. So 2x plus 1 So it goes through at 1, and it would be minus a half there. So I'm just going to go down 2, and it's an equal line, so there's our line. 1 and negative a half. Now, because y is less than or equal to, it should be anywhere below. So what that means is the origin should work in all of these. Let's see if it works here first. Is 0 less than or equal to 1? Yep, so it works there. Let's see if 0 works here. So that y was 0 and x was 0, you'd end up with 3 over 2, which is 1.5. Is that bigger than or equal to 0, 1? It works there, so then it works there, and it works in my diagram, so therefore we've done it all correctly. So that's the checking mechanism. Bit tricky, this one, so make sure you mark and correct what you've done this week on Inequations.